Hello, so this is your physics, and let's start with question number 17. The question says that a mass of 40 kg is being released from a height of 20 meters. The mass is 40 kg. When the rock hits the surface, it has kinetic energy of 32 kilojoules. What is the weight of the rock? So basically, over here, so I forgot to tell this is March 22, and we have already started it, and that's the continuation. So that's question number 17. So basically what over here is happening is that the potential energy is being converted to kinetic energy, which is half mv square. So we need to find the weight mg. H is given as 20, and the kinetic energy is 32 into 10 raised to the power 3. So the weight becomes 1.6 kilonewtons. C is the appropriate answer. So question number 18 says that a metal wire is stretched and obeys Hooke's law. What does not change? The Young modulus does not change. So D is the appropriate answer. Question number 19 says that an object is stretched until it reaches the elastic limit. Elastic limit is the limit from where the object returns to its original length. Which statement must describe the stress on the object when it is at the elastic limit? It is the maximum stress for which the object obeys Hooke's law. No, Hooke's law is not being obeyed at elastic limit, not necessarily. It is the maximum stress that can be applied to the object before it has elastic deformation. No, it is the maximum stress that can be applied to the object before it has plastic deformation. Yes, that's the appropriate answer. Question number 20 says that which statement about progressive wave is correct? So it says that they are all transverse wave. Wrong. They can exist in solid but not liquids. Wrong. They decrease in frequency as their speed increases. Not appropriate. D says that they transfer energy away from the source. Yes, D is the appropriate answer. So question number 21 says that let the CRO find the frequency. You need to find the time period. You can see that in 2.5 cycles, 7 blocks are being completed in 2.5 cycles. So one cycle takes 7 over 2.5 blocks. So one block represents 5 milliseconds. So 5 milli into 7 by 2.5 is 14 milliseconds. So that's the time period. So we need to find the frequency. So what we can say is that 1 over time period is the frequency, which is 71.4 hertz. So B is the appropriate answer. So the next question talks about an ambulance moving towards observer and away from the observer, and asks you to find the change in frequency when it is moving towards and away. You can just plug in the values for f naught fs v over v minus vs and v plus vs. Find the frequencies for both cases and just subtract them to find the change in frequency, which is 91 hertz. So C is the appropriate answer. So question number 23 says that 3 colors of light are emitted from the sun, and which would read first, or in what order would they read? They both are part of the electromagnetic spectrum, which is visible light. So it has the property that they all have the speed of light, which is 3 into 10 to the power 8. So v is equals to f. So they would have the same velocity. So A is the appropriate answer. So question number 24 says that 2 coherent sources which are from different sources meet at a point. What must be satisfied for a zero amplitude at the point? So to make a zero amplitude, the amplitude of one of the wave must be equal to the amplitude of the other wave. So both must have the same amplitude. So D is the appropriate answer. The two waves must have the same amplitude at the point. So question number 25 says that there is a closed end, and a node must be created somewhere here. So what would be the lowest frequency? So what we can do is sketch this up. So the distance is equals to lambda, the length is equals to lambda, and V is equals to F lambda, so frequency would become 330 divided by 13.2, which is 25 Hz. So B, C is the appropriate answer. So question number 26 says that uh, the width gap is D and the wavelength of lambda is being passed, and the width gap is greater than lambda. Which change would cause the largest decrease in the amount of diffraction? Ideal diffraction is when the lambda is equal or greater than the slit separation, and the diffraction gets poorer if the slit separation or width gap is decreased and the lambda is increased. So the width gap is decreased, the width gap is increased and the lambda is decreased. So over here we can see that the width gap must be increased, so that must be 2D, and lambda must be decreased, so that will be lambda by 2. So C is the appropriate answer. So question number 27 says that there are two loudspeakers X and Y which are emitting sound in phase. An observer is moving along that line and the data is given of OY and XY. So you need to realize that path difference is OY minus OX. So the resultant, the path difference is the distance XY. So XY is the path difference which is formed from OY minus X. So it says that the sound which meets, it is in phase. So if the sound is in phase, so that means that that is constructive interference. So if that's constructive interference, so the condition for the path difference of constructive interference is that the lambda must be 0, lambda, 2 lambda, 3 lambda, 4 lambda, and so on. So let's check out for which is the path difference integral multiple of lambda. So 3.5 divided by 0.75 is 4.7 lambda, 2.75 divided by 0.75 is 3.7 lambda, 2 divided by 0.75 is 2.7 lambda, and 1.5 divided by 0.75 is 2 lambda. So B is the appropriate answer. So question number 28 says that on a diffraction grating, which changes would make the first order of intensity maxima further apart from each other on the screen? So basically further apart they are being made if the theta is increased. The theta is increased if the value of the sine theta is increased. The value of the sine theta increases if D is being decreased, or n is increased, or lambda is increased. So from the options, B is the appropriate answer, which says that D is being decreased. So question number 29 says that what is the meaning of n in nave? So that is the number of charge carriers per unit volume. So question number 30 says that electron is given, passes for 24 hours. The total number of electron are 6 into 10 power 23. What is the current? So current is I is equal to Q over T, and Q is Ne over T. So just plug in the values and you will get B 1.1 ampere as the final answer. So question number 31 says that there are lamp P and Q. Their voltage and powers are given, and the power supply is of 250 volts. Which statement is correct? So what we can do is find the resistance of each lamp. For lamp P we can use V square over R, so that would be 1250 ohm, and for lamp Q it would be V square over R, so that would be 312 ohms. So the power of Q would be I square R. I is constant, is the same because that's in series, so I square R 312 over I square 1250, so that would become 1:4. So the power of P is 4 times the power of Q. So lamp P will emit 4 times as much power as lamp Q. So question number 32 talks about to find the resistivity. We are given with the resistance from the graph and we can plug in the value of length, diameter and area. So that would give resistivity as C 4.9 into 10 per meter. Do like and subscribe my channel. In the next video I will continue.